In this session, I'm going to teach you on machine learning and data preprocessing. So, ever since the technical revolution, we have been generating an immeasurable amount of data. As per research, we generate around 3 quintillion bytes of data every single day. It is estimated that by 2022, 2.5 MB of data will be created every second for every person on Earth. So with the availability of so much data, it is finally possible to build predictive models that can study and analyze complex data to find useful insights and deliver more accurate results. Companies such as Netflix, Amazon build such machine learning models by using tons of data in order to identify profitable opportunities and avoid unwanted risks. So here is a list of reasons why machine learning is so important. So increase in data generation. So due to excessive production of data, we need a method that can be used to structure, analyze, and draw insights from data. This is where machine learning comes in. It uses data to solve problems and find solutions to the most complex tasks faced by organization. So I, this explains that there is a lot of data that is being generated over a period of time, and in the coming years as well, you can see that each and every individual will be generating huge amounts of data per second. And we use machine learning for doing predictive for building a predictive models, which can help us to do forecasting and also do the prediction. So next is the improve decision making. By making use of various algorithms, machine learning can be used to make better business decisions. For example, machine learning is used for forecast sales, predict downfall in the stock market, identify risks and anomalies. So as I said, so in the decision making also the machine learning will be helping. Like when we want to predict the stock market upward or downward curve, we can use the historical data, and based on that data, we can train our model and we can make our model to predict the result for the future increase or decrease or rise or fall in the stock prices. Okay. So next is uncover pattern and trends in the data. So finding hidden patterns and extracting key insights from the data is the most essential part of machine learning. By building predictive models and using statistical techniques, machine learning allows you to dig beneath the surface and explore the data in a minute scale. Understanding the data and extracting pattern manually will take days, whereas machine learning algorithms can perform such computation in less than a second. So what happens is that there are some kind of patterns that are actually there in the data, which is normally not possible for a human to find out if he is taking the raw method of finding the insights from the data. But if we use machine learning model, it can actually predict the result within a second. So what cannot be usually done by human within seconds, which takes a hours and days of time, the machine can be able to see the insights and actually give the results within seconds. The next is solve complex problem. So find from detecting the genes like linked to the deadly ALS disease to building self-driving cars, machine learning can be used to solve the most complex problem. So in the medical field, we have seen that some kind of virus that might attack the humans, and we have to find what is the reason, what is the deadly cause for that. So using this, actually, the data can be collected from that virus, and actually we can perform some machine learning models and actually get some insights from that data. So this is how we can solve complex problems. And also even in the self-driving car as well, you can see machine learning is being used because the machine is going to learn from experience. Okay, so machine is not being given any instruction from the outside; it is going to learn from the experience over there. To give you a better understanding of how important machine learning is, let's list down a couple of machine learning applications. So Netflix recommendation engine. The core of Netflix is its infamous recommendation engine. Over 75% of what you watch in what you watch is recommended by Netflix, and these recommendations are made by implementing machine learning. So when you open a Netflix account and when you do the browsing and you watch some web series or TV shows on that Netflix account, you will see that the next time the recommendation will be shown that 98% match or some kind of 90% match. It is telling you that the kind of movies that you have watched, it is actually close to that is recommended by the recommendation engine. Okay, so Netflix is giving some recommendation based on your interest, what kind of interest you have, what kind of movies you usually watch. Based on that, Netflix algorithm works like that, and according to that algorithm, it will actually give you some recommendation, movie recommendation, or TV series recommendation. Next is Facebook auto tag feature. Okay, the logic behind Facebook's DeepMind face verification system is machine learning and neural networks. DeepMind studies the facial features in an image to tag your friends and family. So what happens is that when you were using Facebook from 2010s onwards, you are actually tagging the people's face on that, right? So actually, Facebook was collecting the data, and based on the machine learning and neural network, they were now able to make. They have so much of data collected. They were now able to make the similarities that face contains in their photo, and based on that, it will auto tag. Okay, or to tag your friends or families. So now Amazon Alexa, the infamous Alexa, which is based on natural language processing and machine learning, is an advanced level virtual assistant that does more than just play songs on your playlist. It can book your Uber, connect with another IoT device at home, track your health. So Amazon Alexa is one of the machine learning models that it works on the process of natural language processing and machine learning. It's an assistant. Actually, it works on voice command. Actually, this is based on ML machine learning because it understand it because this is based on natural language processing and also machine learning. It can understand your voice recognition. That is what natural language processing is. And once it understands, it do the processing, and then based on that, it will give some recommendations to you. And whatever you want to, or whatever you want your Amazon Alexa to perform, it does the voice command, and actually it will do whatever command is given by the user. This is based on natural language processing. Next, the Google spam filter. So Google Gmail makes use of machine learning to filter out spam messages. It uses machine learning algorithms and natural language processing to analyze emails in real time and classify them as either spam or not. So what happens is that in Google's, if you go to Gmail, you can see in your spam folder, like there are some of the emails that are contained in your spam folder. So which is like it is made. This kind of filtering is done by the machine learning model. It sees some of the keywords like free or some kind of 25% discount, like that kind of thing, and it actually moves your for mail into spam folder so that you don't need to worry about the inbox that you are actually having. So this is like some of the spam emails that are being generated that are being sent to your email, it will automatically go to spam folder based on natural language processing. This is in the real time data. Okay. So introduction to machine learning. So the term machine learning was first coined by Arthur Samuel in the year 1959. Looking back, that year was probably the most significant in terms of technology advancements. If you browse through the net about what is machine learning, you will get at least hundreds of definitions. However, the first very formal definition was given by Tom and Mitchell. Okay. A computer program is said to be learned from experience E with respect to some class task T and performance measure P if its performance at task in T as measured by P improves with experience. Okay. This is nothing but first you will train your model, and once you train your model, you do the model evaluation. So you then test your model based on some other kind of data. First, it will learn from experience. And once it learns from experience, then you have to see the performance. Okay, performance measure has to be done P. And you give the task T, that is the test data. Then you have already trained using the trained data T. Now you do the test data you do testing using test data and you measure the performance. Okay, performance measurement happens, and based on the performance, we can actually improve the model. Okay, we can improve the accuracy of that model. So it machine actually learns with experience. Okay, it improves with experience. So in simple terms, machine learning is a subset of AI which provides machine the ability to learn automatically and improve from experience without being explicitly programmed to do so. In sense, it is practice of getting machines to solve problems. So what happens is that machine learning is nothing but it is actually learning automatically. In the word itself, it's the machine learning. It learns by automatically without being explicitly programmed on what to do. So, okay, we have used statistical techniques, but it will learn based on its experience only. But wait, can a machine think or make decision? Well, if you feed machine good amount of data, it will learn how to interpret, process, and analyze this data by using machine learning algorithms in order to solve real world problems. Yes, okay. So what happens is that if you have a tons of data, the machine can be able to predict or actually do the thinking just like human beings. But the thing is that it needs a lot of data to understand, analyze, and interpret. Before moving any further, let's discuss some of the most commonly used terminologies. So, what is an algorithm? Okay. So, a machine learning algorithm is a set of rules and statistical techniques. Okay. So, you have to understand it. It's a rules and statistical techniques used to learn pattern from the data. Okay. Machine learning algorithm is a set of rules and techniques used to learn patterns from the data and or inside draw significant information from it. Okay. So it is a logic behind machine learning model. An example of machine learning algorithm is the linear regression algorithm. That is I'm going to teach you in the coming sections. Okay. So what happens is that it is just a set of rules and some mathematical, as that is statistical techniques used to learn from the data and draw significant information from the. So we have to feed the data into the algorithm, and that machine is going to draw significant information from it. This is the logic behind the machine learning model. Model is a main component of machine learning. A model is trained by using a machine learning algorithm. Okay, model is nothing but you take the algorithm and you feed the data into that algorithm and you train that model and to train your model. That is whatever outcome it comes when you use an algorithm to train your data using an algorithm, that is going to be your model. So a model is a main component of machine learning. A model is trained by using a machine learning algorithm. Okay, so model is nothing but training a machine learning algorithm. An algorithm maps all the decisions that a model is supposed to take based on given input in order to get the correct outcome. So it's nothing but an algorithm maps all decisions. So whatever data you have, you feed it to the algorithm, and based on that, the algorithm or the model, I would say, because once you train your algorithm with some data, it becomes a model, and based on the input, your model is going to predict what kind of output you might get. Okay, so let's come to predictor variable. It is a feature of the data that can be used to predict the output. Okay, so predictor variable is nothing but independent variables. That is, whatever independent variables are there, which is which is useful for predicting. Okay, so a predictor variable is your independent variable, and response variable is your dependent variable. That is, responsive variable is the output. Let me explain you over here. Okay, so it is a feature of the data that can be used to predict the output. So this is the predictor variable. This, like, let's consider this as a data with rows and columns. So these are the columns, let's say, and these columns are independent columns, and this Y column is the dependent column. That is, based on these independent columns, the Y column can be predicted. Okay, that is what called as predictor variable. These called as the independent variables which are not dependent on each other, but the dependent variable will be dependent on whole of this independent variable, This is known as y is known as response variable. And these x1, x2, x3, x4, x5, 6 are known as independent variables. So it's a feature or features of the data that can be used to predict the output. This is the output, which these features used to predict the output is known as predictor variable. And response variable is the feature of the output variable that these days that needs to be predicted by using the predictor variable. Using this, we are going to predict the y variable. Okay. So training data, the machine learning model is built using the training data. Okay. So whatever model you are going to build in a machine learning, it is actually built by training data. So whatever data you are collected using web scraping or some other techniques so that are present. So using that, whatever data you have, you train your model by applying an algorithm. Okay. The training data helps the model to identify key trends and patterns essentially to predict the output. Okay. So whatever model is built, that is built on the training data. Okay. So when you have a data, let's say you have a thousands of rows. Okay, let's say you have a thousands of rows. So now what you do, you have to split that data into training and data, testing data. Okay. So what happens is that when you split that data, first you will actually train your model with 80% of the data. Let's say 70 to 80%. It depends. Okay, 70 to 80% depends on how many records are there. Let's say I'm taking 70%. So out of 1,000, we are taking 700 records to train your data. That is, you'll pass x1, x and y, okay, independent and dependent variable to train your data. Next, in the next case, you have to test if the model is giving correct accuracy or not. Then you will pass the testing data, okay. What is that testing data? From a 701 column, 701 row record to 8,000 record, okay. So you will pass the testing data, but you are not passing the output variable, okay. So you are not passing, you are actually predicting, right? So whatever results you get, you compare it with the target response, and you will see how much accuracy you will get. So and also you can also see for the training accuracy as well. So first you'll pass these independent variables and dependent variable and train your model. The next time you'll pass only the independent variable but not the dependent variable, and you'll see the results of this independent variable, and you just actually whatever output you will get, you will compare with the dependent variable one. This is for training accuracy. Next, for testing accuracy, you have not actually made this data present. You have not made this data available for the model before. So what you will do, you have to test your model accuracy. So you will pass this testing data, but you are not going to pass this training data. But whatever result you get output, you will compare it with the testing accuracy. So this is what happens. Okay, testing data after the model is trained, it must be tested to evaluate how accurately it can predict an outcome. So this is done by testing data. So let's say we have a child and you are going to teach addition operation. Okay, so we have giving a is equal to 15 and b is equal to 12, and you are teaching the child how to do the addition operation like 5 plus 2 7 and 1 plus 1 2. So now this is like a training. Okay, training the child on how to do. You will give inputs x y x, that is independent variable a and b and dependent variable y. You will teach the child. Okay, the next time you give a test, you will give some other values, right? So next you will say that do the performance of or perform addition of this. Okay, so and then they will check what is the answer the child give. The child gave 27 as the answer. Okay, 2 plus 7, 7 and 1 plus 2, but you know that answer is 29. So then you have to see what kind of accuracy you get. So this is wrong, right? So you will see the testing accuracy also comes into picture. Once you have trained your child, you have to see, you have to test the child if he is giving the correct answer or not. So if you are giving the same data and giving and not letting the child what is the answer, like you have already previously exposed this data, right? 15 and 12. Now you are telling the child to check what is the tell the answer. Okay, so and the child predict 27. This comes out to be training accuracy 100 because you had already trained it more. But when you give some other unexposed data to the child and gives 27 as the answer, which is opposed to 29, then we will say training testing accuracy is not so good. So testing accuracy and training accuracy should be high. It should be almost more than 90-95%. And also the difference between testing accuracy and training accuracy should not be maximum, and it should be minimum as possible. Okay, and also overfitting, I will teach the concept regarding overfitting in the later classes. So now let's come to the machine learning process. Okay, So the machine learning process involves building a predictive model, okay, that can be used to find solution for a problem statement. To understand the machine learning process, let's assume that you have been given a problem that needs to be solved using machine learning. So you have been given a machine learning problem, okay? You need to solve it by machine learning using machine learning. So what are the questions you will ask? Well, first, you know that you will define objective. What is the objective? What you have to find? Okay, what is the main insights? What is the main objective of your problem statement? Then you will gather data. Data gathering can be done in the online websites for using web scraping, or you can actually get it on Kaggle as well. So that kind of thing actually you have to data gather. You have to look at where can I get the data. Once you get the data can may not be in the proper format. So then you have to do the preparation of data. Like there can be some columns are missing, some column values are missing, some rows values are missing. So you can have to do the preparing of the data. So then once the preparing of the data is done, then you have to do data explorations. I'm going to teach you this data exploration. So once the data exploration is done, what you will do, you will have to build a model and then you have to train your model and do the model evaluation. Okay. So building a model is like a training an algorithm. Okay. And then you have to, once model evaluation is done, and you have to do the prediction for the untested data, that is unexposed data. So this is the process. So let me teach you in depth. So the problem is to predict the occurrence of rain in our local area by using machine learning. So the steps that are followed by machine learning process is step one, define the objective of the problem statement. At this step, you must understand what exactly needs to be predicted. Okay. Here, what exactly needs to be predicted? If it is going to rain or not. In our case, the objective is to predict the possibility of a rain by studying weather conditions. At this stage, it is also essential to take mental notes on what kind of data can be used to solve this problem or type of approach you must be following to get the solution. Okay. So the first one is the problem statement. What is the problem statement and how are you going to collect the data? That you have to understand. Okay. Then data gathering. At this stage, you must be asking questions like what kind of data is needed to solve this problem? Is the data available? How can I get the data? Once you know the types of data that is required, you must understand how you can derive the data. Data collection can be done manually or by web scraping. However, if you are a beginner and you're just looking to learn machine learning, you don't have to worry about getting the data. There are thousands of data resources in the web. You just download the data set and get going. Okay. So coming back to the problems at hand, the data needed for weather forecasting includes measures such as humidity level, temperature, pressure, locality. Whether or not you live in hill station, such as data can be collected and stored for analysis. Okay? So this is all about data gathering. Now you have to prepare the data, that is data preparation. The data you collected is almost never in the right format. Okay, you will encounter a lot of inconsistencies in the data, such as missing values, redundant variables, duplicate values. Removing such inconsistencies is very essential because they might lead to wrongful computation and wrongful prediction. Okay, this is so much danger. Okay, so we have to take care of the data. Okay, data preparation is one of the important steps involved in the machine learning process. So therefore, order. So this is actually comes under the data. So as I was telling you, the data you collected is almost never in the right format. You will encounter a lot of inconsistencies in data sets, such as missing values, redundant variables, duplicate values. Removing such inconsistencies is very essential because they might lead to wrongful computation and predictions. Okay. Therefore, at this stage, you scan the data set for any inconsistencies and you fix them then and there. So then we comes to the exploratory data analysis. So grab your detective glass because these stages are all about diving deep into the data and finding all the hidden data mysteries. Exploratory data analysis is the brainstorming stage of machine learning. So data exploration involves understanding the patterns and trends in the data. At this stage, all the useful insights are drawn correlation, between the variables are understood. Okay. For example, in case of predicting rainfall, we know that there is a strong possibility of rain if the temperature has fallen. So such correlation must be understood and mapped at this stage. Okay. This is all about exploratory data analysis. So next, we will once exploratory of the data is done, then we will build a model. Okay, building all the insights and patterns derived during that exploratory data analysis are used to build the machine learning model. The stages always begins by splitting the data set into two parts: training data and testing data. So I had already talked about this training and testing data. The training data will be used to build and analyze the model. The logic of the model is based on machine learning algorithm that is being implemented. In the case of predicting rainfall, since the output will be in the form of true or false, we can use a classification algorithm such as logistic regression. Choosing the right algorithm depends on the type of problem you are solving, the data set, and the level of complexity of the problem. In the upcoming sections, we will discuss the different types of problems that can be solved by using machine learning algorithms. So then, once the model building is done, now we have to put your model into evaluation. So, model evaluation and optimization. So, building a model by using the training data set, it is a finally time to put the model into it. So, the testing data that is present, which is not actually shown to the model, that is the data set is used to check the efficiency of the model and how accurately it can predict the outcome. Once the accuracy is calculated, any further improvements of the model can be implemented at this stage. Methods like parameter tuning and cross validation can be used to improve the performance of the model. So this is like whatever unexposed data you have, you are going to apply that unexposed data into your model and do the evaluation based on the accuracy. Then you are going to tell if how much your model is giving true correct results or wrong results. Okay. Then once model evaluation is done, then we'll do the predictions. Once the model is evaluated and improved, it is finally used to make predictions. Okay. The final output can be categorical variable or it can be continuous quantity. Categorical like true or false, or continuous quantity like prediction of stock market, value of stocks. In our case, for predicting the occurrence of rainfall, the output will be categorical location. That will be the entire machine learning process. Time to learn of the different ways in machine which machines can learn. In step eight, if when you're working in company, you will see that you have to do the deployment part. It's like once the predictions are done and if it's giving accuracy, you have to deploy for the public to usage. Then after that, if there is any bugs or errors comes, you have to modify that. Then we'll build the dashboard and see the results and or the performance of the model that is being built over a period of time. Like over a period of time, we will check what kind of accuracy it's giving for the exposed data. So now let's coming to machine learning types. Okay, a machine can learn to solve problems by following any of the following three approaches. These are the three ways in which machine can learn: supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is a technique in which we teach or train the machine using data which is well labeled. Labeled in the sense you know the output, that is the being labeled. You are actually labeling the data. Okay. So to understand the supervised learning, let's consider an analogy. As kids, we all needed guidance to solve math problem. A teacher helped us to understand what addition is and how it is done. Similarly, you can think of supervised learning as a type of machine learning that involves guide. The labeled data set is the teacher that will train you to understand patterns in the data. The labeled data set is nothing but training data set. Okay. So these are the, let's take an example where consider the above figure. Here we are feeding machine images of Tom and Jerry. Okay. So these are labeled data because we have labeled it as Tom here for this and Jerry for this. Okay. And the goal is to the machine is to identify the classes the images into two groups. Okay. Tom images and Jerry images. The training data set that is fed to the model is labeled as in we are telling the machine. So we have actually labeled the training set. This is how Tom looks and this is how Jerry looks. Okay. By doing so, you are training the machine by using label data. In supervised learning, there's a well-defined training phase. So once the training has been done, now we have to see the testing. Okay, model evaluation has to be done. So you will pass this image, and that machine will predict this is class Jerry, belongs to class Jerry, and when you pass this, this belongs to class Tom. Okay, this is how the supervised machine learning stress works. Okay. Now, in unsupervised learning, we have unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without guidance. Okay. Think of unsupervised learning as a smart kid that learns without any guidance. In this type of machine learning, the model is not fed with the labeled data, as in the model has no clue that this image is for Tom and this is Jerry. It figures out patterns and the difference between Tom and Jerry on its own by taking tons of data. Let's say, for an example, it identifies prominent features of Tom, such as pointy ears, bigger size, to understand that the image is of type 1. Similarly, it finds such features in Jerry, like short and has a tail. Obviously, both has a tail, and this is short. Okay, so therefore, it classifies the image into two different classes without knowing who Tom is or who Jerry is. So this is all about the unsupervised learning. Reinforcement learning is a part of machine learning where an agent is put in an environment and he learns to behave in this environment by performing certain actions and observing the rewards, which it gets from those actions. This type of machine learning is comparatively different. Imagine that you were dropped off an isolated island. What would you do? Panic. Yes, of course. Initially, we would all do, but as time passes, you will learn how to live on that island. We will explore the environment, understand the climate conditions, the type of food that grows there, the dangers of that island. This is how exactly reinforcement learning works. It involves an agent and that is put in an environment and which is unknown, where he must learn by observing and performing actions that result in rewards. Reinforcement learning is mainly used in advanced machine learning areas such as self-driving for cars and alpha. You don't have to worry about the reinforcement learning because in machine learning only we are discussing supervised and unsupervised machine learning. The reinforcement learning is used in advanced machine learning, which is not used in industries. Okay, the main focus will be in supervised and unsupervised machine learning. So the types of problems in machine learning. So in machine learning, we have supervised learning, unsupervised learning, and reinforcement learning. In supervised, we have classification and regression, and in unsupervised, we have clustering. So consider the above figure. There are three main types of problem that can be solved in machine learning. So regression. In this type of problem, the output is a continuous quantity. Okay. So for our example, if you want to predict the speed of the car given the distance, it is regression problem. Regression problems can be solved using supervised learning algorithms like linear regression. So next come to classification. In this type of problem, the output is a categorical variable. Classifying emails into two classes, spam or not spam, is a classification problem that can be solved by using supervised learning classification algorithms such as support vector, machine naive based logistic regression, and k-means. So next to clustering. Okay, this type of problems involves assigning the input into two or more clusters based on a feature similarity. For example, clustering viewers into similar groups based on their interest, age group, geography. It can be done by using unsupervised learning algorithm like k-means clustering. I'm going to teach all these algorithms in the coming videos. So here's a table that sums up the difference between regression, classification, and clustering. In regression, it's supervised learning, and classification is supervised learning, whereas clustering is an unsupervised learning. Output is continuous quantity, like prediction of stock market. Output is a categorical quantity, like spam or not spam. It's a categorical variable. It's like a classification. Assign data points into clusters. Okay, this is clustering. We don't have like we are grouping into clusters without a label data. So main aim is to forecast or predict. Okay, here. So main aim is to computer is to categorize the data. So main aim is to group similar items together. Okay, group similar items into form of clusters. This I have already told. So the prediction, stock market price, classification is spam or not. And this clustering, it's all about finding all transactions which are fraudulent in nature. So if you have like millions of records with transactions and you have to find the fraudulent transaction, you have used clustering. Okay, what kind of how at what time the fraudulent transactions happen, what are the reasons of fraudulent transactions, like that kind of similarities we'll check. Algorithm here in regression is linear regression. Algorithm is logistic regression, I-based, support vector machine, and even k nearest neighbors. And here we have clustering. We have k means clustering. Okay, this is all about the machine learning introduction. So let's move to the descriptive statistics before moving to the data processing. Okay, now I'm going to the test data processing. So before moving to the data processing, let me tell you, when you are going to do the training of your model, you usually take training data to be 70-30, 75-25, or 80-20 ratio. Okay, this is the ratio of how the data will be split. So once you have the data, so training data, you will train your model, X-train and Y-train. So here is the Y-train, you pass the model and train your model for X-train, this is the Y-train. And then once the training has been done, you will pass again the independent variable of X. But now we are not showing the Y-train. Then you will tell the model to predict the Y-train, and white train prediction, whatever is done, you will compare it with white train and see the accuracy. Okay, so what kind of accuracy you will get. Similarly, testing, we haven't exposed this data to the model, so you will pass the excess data, and then you will actually whatever you test the test, you will get white prediction. Okay, so you will get the white prediction, and white prediction we will compare with the white test which is not exposed to the model, and you will see the testing accuracy. Okay, so this is about the machine learning introduction. So now let me teach you the data processing. In data pre-processing, we need to extract target variable and extract predictor variable. The extract target variable in the sense the x variable, okay, x data. You have to extract target variables and predictor variable. Here, target variables is the y variable, and let me check this. Okay, target variable with the y variable and predictor variable with the x variable. We have to extract that. So we can extract that variables using log.iloc name or name of the column path. LOC is used to select rows and columns by names or labels. .ilec is used to select rows and columns by integer and index position. So, but you are actually trying to extract the column, right? So you can extract the column using .loc, or name of the column you will pass, okay? Okay, and also, if you want to extract the predictor variable, you will actually pass the same. You do. So this is the target variable. Sorry, this is the target variable. So target variable column you will extract like that. Okay, in form of accessing the column. So extracting predictor variable is like it, or you can extract it by using LOC or LOC or using names. Names in the sense you can pass names in the form of list, what columns you want, or you can do the slicing operation. This is how you can extract target variable, that is y, and predictor variable, that is x. So now we have the x and y. So what you have to do is that, so you have all got x and y. So whatever x and y you have got, you have to split the data in such a way that you will get 20% of the data as training data and 20% of the data as testing data. Okay. So we have from sklearn.model selection, we import train test split. So train test split function of is a function of sklearn.model selection package. In Python, splits arrays or matrices into random subsets for training and testing data. Okay, this data is splitted like a randomly. 80% of the data is splitted for training, and 20% of the data, whatever 80% is used, the 20% of not used will be automatically used for testing data. Okay, so you don't have to pass test size. You can either pass train size or test size, and random state is used to fix. Okay, so when you run this program again, you don't want the data to be once again changing. Okay, when you have you if you want the data to be fixed once the extend and or x test data x-ray for training and testing data to be fixed, if you don't want that to change when you run the program once again, you keep a random state of is equal to some value. Okay, you have to keep some value when you run the same code. It will be fixed. Okay, that whatever split happened and whatever data is there in the train will be there in the train once again when you run the code. So this is all about that train test split. So you pass you import from sklearn.model selection import train test split, and you will pass xtrain comma xtest and ytrain comma ytest. In xtrain you will have independent variable, and xtest will have dependent variable which are used for testing only, and ytrain you will have the dependent variable train, and ytest you will have independent dependent variable test. Okay, so now you'll perform stain test split, and you'll pass the data that you have accessed from this predictor and target variable, and then pass stain size, and I have told why random state. It is used to fix the data once you run the code. Okay, training and testing data to fix. How to handle missing values. So now in the data preprocessing, the fourth step, after the first three steps is happened. So now let's do the fourth step. Fourth step is like how to handle missing values. When you extract data from some source, you will see that there are some missing values that are present. You have to do handle those missing values. It can be done by filling it with mean, median, or mode. Mean is used for unskewed data. That is, if you don't have an outlier, then you can go with mean. Median is used if you have a skewed data. That is, if you have an outlier in your data, then you can go with median. And mode is used when there is a categorical data. So then the next way to handle missing value is omission. Omit the row if your missing value is more than 90%. So if your row contains more than 90% of data missing, then just omit that row, and omit the column if a missing value of the column is more than 90 plus percent. Okay, so this is the second way. Or you can do backward or forward fill. df dot b fill, whatever data frame dot b fill you have, it will, or so it will take the next whatever current value is there, the previous value will be filled. Okay, whatever previous value is there, that will be filled for the current value as well. And forward fill is df dot ffill. df dot b fill is backward fill. df dot ffill is forward fill. So the next value, whatever is there, that will be filled for the current value. So it's like if this data is missing, so whatever is this is value is there from the sales, it will be putting the same value to this um, this record as well. Okay, here also here for sales, here also it will fill if you put backward fill, and if you put forward fill, then the whatever the next value is there, it will come in the previous box. Okay, other ways to handle the data missing values is drop NA. Drop NA is like you are dropping not available or null values. Or you can fill NA. Fill NA in the sense you can fill NA values with some constant values like whatever value you want. So fill that values wherever NA is there. Or impute. Impute in the sense from sklearn import simple imputer. Simple imputer where missing values is np.nan. Wherever np.nan, that is null values are there, just they just pass the mean value over there. Strategy is equal to n. This is how simple imputer works. So simple is scale from sklearn dot import from sklearn import simple imputer. So simple imputer, under that we have parameters missing values as np.na, which is null values, and strategy, whatever strategy you want to apply, that is mean value you want to fill that wherever null values that you apply. So next, how to find the number of missing values. If you want to find the number of missing values, just apply dot isNA. Okay, it will give the null values present or not, true or false. So whatever true is there, just do the dot sum. Okay, so it will give the missing values total number. Or you can do is null dot sum as well. So find the number of missing values. Once this is done, then you have to standardize the data. Okay, standardizing the data is usually preferred when the data is being used for multivariate analysis. That is when we want all variables of comparable units. Let's take an example where we have age and salary column. You see that age column is usually for 20 to 80. Let's say age is between 20 and 80. Salary is starting from 10,000 till 1 lakh. So you see that these are not comparable units. Okay, this range is from 80 to 100, and this is from 10,000 till 1 lakh. So what standardization of data does is that it is used for multivariate analysis like this. That is when we want the variables in the comparable unit. We will scale this data in such a way that this salary also lies in that range. So between -3 and 3, and this age also lies in that way, maybe between -3 and 3, using z-score method if you follow for standard scaler. Okay, so this is like standardizing the data. I actually taught you that standard normal distribution where if you want to compare the scores of happy and Ekta, the scores scored in math and English test, that's how we have done standardization of data. So in programming, we do like this, okay? Standard scalar from SQL and word preprocessing, import standard scalar, okay? So standard scalar is an algorithm for standardization of the data set. The idea behind standard scalar is that it will transform your data such that its distribution will have mean value of 0 and standard deviation of 1. Okay. So STD is standard scalar. So standard dot. So in cases of multivariate data like this, age and salary, this is done in feature scale wise. Okay, feature wise. In order, like feature wise in the sense, this salary and age are independent. So what we will do, we'll transform the data for this independently and for this independently in such a way that our mean value is 0 and standard deviation is 1. Okay, this is the idea behind standard scalar. Given the distribution of the data, each value in the data set will have mean value subtracted and then divided by the standard deviation. This is like z is x minus mu by sigma, right? So let's take an age. What for age? Okay, we have to do the standard scalar, that is scaling of age. So let's take 36 is the age. So let's take the mean to be some 40. Let's take it as the mean to be 30. Okay, 36 minus 30 by sigma. Standard deviation, let's take some value. But what happens is that let it start x minus mu by sigma, like that when you do then you are doing the standardization of data x minus mu by sigma. So whatever mean comes, mean, that is x minus mu by sigma. So sigma you will calculate based on that formula that is there for standard for finding the this thing. Okay, standard deviation, sorry, variance and standard deviation. Yes. Okay, so given the distribution of the data, each value in the data set will have mean value, okay, subtracted and then divided by the standard deviation of the whole data set. So that is age, a point of age, or data value, that is as each value of age is the minus subtracted by the mean value of age divided by the standard deviation for age column. Similarly, salary will be data value at if each value of salary is subtracted by mean value of salary divided by standard deviation of the salary. Okay, this is how this is we do this because we have to transform our data. I mean, it's like you have to see, you want even age and salary to be in the comparable units because their range is bit different, right? So we want in the same range where even this for this also and this also we have mu is equal to 0 and standard deviation of 1, and they are in a comparable units. So in data science, that fit transform, if I have to say, in data science and machine learning, the method is like fit transform, and fit transform provides by scikit-learn package are one of the tools that are extensively used in data processing and model fitting. The fit of data this the fit of data method is used to compute the mean and standard deviation calculated using the fit method. Okay, that is, the fit method is used to compute the mean and standard deviation for a given feature to be used for further scaling. The transform method is used for performing scaling using mean and standard deviation calculated using dot fit method. So this dot fit method will give mean and standard deviation, and the transform will transform the dirty scale the data using the mean and standard deviation, and the whole of fit transform method does both fits and transform. That is, it finds mean and standard deviation, and then after that, it will do the scaling using mean and standard deviation that is calculated using fit data. There is another way of data scaling where the minimum of the feature. This is like you have to understand this standard scaler is using z-score method. Okay, z-score method in the sense that is x minus mu by sigma, right? So it is using z-score method to standardize the data. In min-max scaler, there is another way of data scaling where minimum of the feature is made equal to 0 and maximum of the feature is made equal to 1. Min-max scalar shrinks the data within given range, usually 0 to 1. It transforms data by scaling features to a given range. Okay, it scales the value to a specified values range between changing the shape of without changing the shape of the original distribution. So you consider this value in a data set 1, 2, 3, 4, 5, 6. So if you want to find the using min-max scalar, if you want to find, so let's take a point here, okay? See 3. Let's take 3. So this is the formula for min-max scalar, x minus x min by x max minus x min. So x is 3, 3 minus min, 1 minus x max is 6 minus 1, 5. So 3 minus 1 is 2 by 5.4. So it will min-max scalar will scale the data between 0 and 1. If there are negative values that are present in your data set, then the scaling will happen between minus 1 and 1. Okay. This is how min-max scalar work. So if you want to use the min-max scalar, then you have to from the scalar dot preprocessing, you have to import min-max scalar, then min-max scalar dot fit transform of whatever data frame, pass the data frame columns that you want to do the scaling. Once you have done the scaling and standardized or using standard scalar or min-max scalar, then you have to do the encoding of the data. So whenever we're dealing with categorical variable, it needs to be get transformed into numerical variables because machine won't understand English language. Okay, it understand only languages in the form of numbers, that is zeros and ones. So you have to make sure that whatever categorical value is there, it needs to be transformed into numerical values. Okay, the model can perform arithmetic operation on this kind of data only. Okay, so once you have converted your categorical variable into numerical values, then you can perform, you can then model can make operation on this data. So in encoding, let me teach you first about label encoding and one-hot encoding before teaching pd.get dummies. So in encoding, we have label encoding and one-hot encoding. So label encoding is a technique that is used to convert the categorical columns into numerical ones. So let's say we have a gender column. In gender column, let's say we have male, female, and others. Okay, this is the gender column, and we have male, females, and other. Once you do the encoding, you will have some values like 0. Let me explain it in a sense. Label encoding is a technique that is used to convert categorical variables into numerical ones so that they can be fitted by machine learning models which can only take numerical data. It's an important pre-processing step in a machine learning project. Okay. So example of label encoding I have shown. Suppose we have a column called gender in some data set that is has elements male, female, and others. To convert this categorical column into a numerical column, we apply label encoding to this column. After label encoding, the male will be encoded to 0. Okay. The male column is converted into a numerical column. this gender column is converted into a numerical columns of 0, 1, 2, where 0 is the label for male and 1 is the label for female and 2 is the label for others. Okay. So this is how the label encoding works. And there is no order on how the machine is going to choose how it is going to choose male as 0, female as 1. So we don't have that option. The machine internally is going to decide that. So 0, 1, and 2 gender. So this is how label encoding works. It will convert the columns of gender into an encoded value of 0, 1, 2, where 0 represents male, 1 represents female, and 2 represents other. So for this, we have to from cycle sklearn.preprocessing, we have to import label encoder. And in label encoder, we have to dot fit transform. So dot fit transform of you have to pass the categorical data, that is gender data frame, which is all about label encoding. Now let's come to one-hot encoding. So it is a technique, one-hot encoding is a technique that we use to represent categorical variables as numerical values in machine learning model as well. In one-hot encoding, the categorical parameters will prepare separate columns. For gender, we had these three values, right? So separate value of gender male, gender female, and genders others will get created. So we'll create separate columns for both male, female, and others. So whatever value is male is value will be 0. The female column will be having value as what? So sorry. So wherever there is male, the value will be 1. Okay. So let's say male is there in this column. So we have male 1, 0, the others will be 0. And we have female next. So 1, 0, 1, 0, others will be 0. And female once again. So we have 1 year, others will be 0. And then is there the other gender. Then we have 1 year and others 0. Similarly like that. Okay. It is like, so wherever there is a male, the value will be 1 in male and column and 0 in the female column and others column, and vice versa. Wherever female is there, the value will be 1 in the female column and 0 in the male and others column. And wherever the others is there, the other two columns will be 0 and others will be 1. Okay, now let me this for you are accessing one hot encoding from sklearn.preprocessing, import one hot encoding and one hot encoding dot fit transform of pass the categorical data frame, categorical column in the data frame. Next, let's come to PD dot get dummies. Okay. So the get dummies method in pandas provides a convenient way to perform one-hot encoding on data. It can handle both nominal and ordinal categorical variables and provides several options for handling missing values and controlling the prefix and suffixes of the new columns. So it's one PD.get dummy is like converts categorical variable into dummy. Okay, pd.get dummies. It's like, let's say we have a list of ABCBA. So this is the values that are present in our con column. What it will do is that a new column will be created with these variable names, but it won't be repeated. So A, B, C are unique values. So three columns will be repeated. Wherever A is there, it will be 1. 1, 0, the others will be 0. Next B is 1, others will be 0. Next C is 1, others will be 0. Next once again B will be 1, others will be 0. Next A is 1, others will be 0. So this is similar to what one-hot encoding does, but the difference is that if it is one-hot encoding is belong to scikit-learn package, whereas this PD get dummies belongs to pandas package. Okay. So here also each variable is converted and as many zeros or one variables as there are different values. Columns in the output are named after value. If the input is data frame, the name of the original variable is depend to be the value. So let me see the difference between that. So the difference between one not and get dummies. Both one not and get dummies give the same result, but there are some important difference between them. The get dummies can't handle the unknown category during the transformation natively. You have to apply some techniques to handle it, but it is not sufficient. On the other hand, one not encoder will natively handle unknown categories also. All you need to know is the parameter handle unknown is equal to ignore to unknown. For example, in the tips dataset, you have been seen above the day column contains four unique values: Thursday, Friday, Saturday, and Sunday. If the data set test data contains a new category, say Monday or Tuesday, then the get dummies will create a new column day, Monday, or Tuesday, which will inconsistent with train data and will eventually fail during the model building process. Okay, so let's see what happens. So when you have this, so get dummies example. The get dummies method doesn't store the information about the trained data categories, hence it may result in inconsistencies with train and test data feature. In the below example, X test new contains only two categories, Sunday and Monday. Okay, so it has only two categories, Sunday and Monday. As expected, get dummies will create only two columns, day, Monday, and Sunday. Okay, which is inconsistent. The trade data columns, the get dummies doesn't have knowledge about train data columns. So Sunday, day, Monday. Okay, day Sunday and day Monday will be created. Now let's say the get dummies. Let's say you have passed some other values as well. Like let's say you have Friday as well. So let me see. Though get dummies can't handle unknown categories natively, you could get around this inconsistency by applying a below technique. This is not so useful. Basically, it's like, see, let's say you have Sunday and Monday. It will create day Monday and day Sunday. Okay, pd.getDummies. But if you pass some Tuesday, then that time it will create problem. But when you do one not encoding and you have only Sunday and Monday, okay, but you see, let me show you this. Okay, Monday and Sunday are the columns that are created using getDummies. And now you have Thursday, Friday, Saturday, Sunday columns that is created using getDummies. But you see there is another value Monday that is being faded. Okay. Then some kind of inconsistency that happens over here because Monday is present whereas it is not present over here. But here what it does is that one not encoder, it just simply makes all the values zeros if there are some inconsistency. Okay, we make it pd dot ignore, like we have to ignore handle ignore non is equal to ignore in one not encoding which is present. So this is about one not encoder. So mostly we will use one not encoder. So the summary is the one hot encoding is one of the categorical data encoding techniques. There is two popular and commonly used scikit-learn, one not encoder, and pandas get miss method. Both achieve the same result. If you are building the machine learning model, then go for one not encoder. And for data analysis tasks, you can consider one not encoder or either get dummies. Okay, I would refer you to use one not encoder because it's a good practice because the unknown data will be handled in a more careful way. So this is all about the data pre-processing techniques. In the coming later section, I am going to teach you about the linear regression model. Okay. Thank you for attending the session.